Okay.
All right, we're looking at number 4 on your week 2 packet. Before we can graph this equation, we've got to change it into y-intercept form. Y equals mx plus b. That's what I'm shooting for. So I know that I have to make Mr. Y happy. Right? I've also got a trick I'm going to use. Don't call me after midnight. That stands for distribute, combine like terms, move variables, add and subtract, multiply and divide. This is the order that I'm going to use to get this the way I need it. So first things first. I got a whole bunch of junk going on over here on the same side as Mr. Y. So I've got to start moving stuff. Distribute. Do I have anything to distribute?
Not really, no.
No, I have nothing to distribute. Do I have any like terms to combine? I've got X family, Y family, plain Jane family.
No, you don't.
No, there's nothing to combine. All right, stuff to move. Do I have anything over here that needs to be moved to the other side?
You can do the 6x, like you can subtract 6x on both sides.
Absolutely. Negative 6x, what I do to one side, do to the other.
After the other.
So that cancels. I'm going to move down my 12y plus 24 equals negative 6x. I don't really have to do anything with the 0. It can
because it's just 0.
Right, it's not going to change anything. All right. Now, do I still have anything to move?
Wouldn't you do negative 12 divide on both sides? I mean,
Not
all sides?
Yet. Not yet. This moves together as a unit. This moves together as a unit, just like we moved this whole thing. So what I need to do to try to get Mr. Y by itself, I need to move the big chunks first. So is there another big chunk that's bugging this whole negative 12y thing?
The positive 24?
Positive 24, absolutely
so
right.
So you subtract that on both sides?
Yes, ma'am. Negative 24, negative 24. These cancel. So I'm going to just rewrite what I've got to my brand new equation. Bring negative 6x down, minus 24. Now, I could not put these together because this is the X family, this is the plain Jane family. You can't put families together. They have to be separate. Right?
So now you divide by negative 12 on all sides?
Yes, ma'am. Because we're trying to make Mr. Y happy. The operation happening between negative 12 and Y is multiplication. To undo multiplication, I have to divide. And what I do to one side, I do to the whole other side. So those cancel. Y is suddenly very, very happy because he's all by himself. Negative 6 divided by negative 12 should give me positive 1/2. Negative 24 divided by negative 12 should give me positive 2. Good deal.
So it'd just be plus 2?
Uh-huh.
Okay.
That makes sense how I got that.
Okay. I understand it.
Now I'm going to swap back to the other screen so that we can actually graph it. All right, here's what we came up with. We got y equals 1/2 x plus 2. Now on my graph, there's no lines. So let me struggle with this thing for just a second and get us some lines drawn here. All right, now I got some lines. First thing we're going to look at is our starting point. That is this. That's our y-intercept. And I know this is my y-axis because it runs up and down. So I'm going to start at positive 2. Positive 2 goes up. So we're going to go up 1, 2. Here's where I start. And this is my slope. This is the m of my equation. And I know that that means rise over run. Rise has to do with my up and down. Run has to do with my side to side.
So you'd go up 2 and to the left once?
You got that backwards. We're going to go up 1.
Okay.
And then we're going to go to the right 2. Because this is positive, so this is like walking uphill. So my line has to look like this. It has to be that shape. So I'm going to start here and go up 1, go over 2. 1, 2. So that's another point on my line. To make a good, pretty line, it's probably a good idea to have another point. So I can keep going either direction as long as it follows that shape. So I'm going to go the other way just because I can. I'm going to go down 1 and to the left 2. And my line ends up like this, sort of. Make sense?
Yes, ma'am.
Right. And the other one you said was number 5 on the next page.
5, 6, 7, and 8.
Okay. Right, let me swap back over. Right, number 5. Our original equation is negative 150x plus 5y equals 300. Is that in a form where I can graph it just like it is?
No.
No, it's not.
No, because
We're looking for y equals mx plus b, our BFF. We have dealt with that so many times. All right, I know, just like I've done before, I'm trying to make Mr. Y happy. I'm trying to get y by itself. What I'm trying to get to. All right. Don't call me after midnight. Do I have anything to distribute?
no, ma'am.
No. Do I have anything to combine? Any families that need to be put together?
No, ma'am.
Nope. Do I have anything to move?
No, ma'am.
Mr. Y is trying to be by himself. Remember, he's a grouchy old man. He doesn't want anything beside him. And this
So you just do.
And this is a unit. And this is a unit. Are there any units on the side with Mr. Y?
The positive 300.
On the same side, in the same room.
The negative 150.
Right, negative 150x. So we have to move this whole thing together as a unit. So how do I undo negative 150x?
You do plus 150 on both sides?
Positive 150x. So what I do to one side,
You have to do the other.
I have to do to the other. So that cancels.
That would cancel, so you're left with 5y.
Uh-huh.
And then you're left with 450.
Can I put those together?
Oh, no. So it should be 300 plus 150x.
Why do I have to leave them separate?
Because they're not in the same family.
Exactly. They're not in the same family. And the smart way to say that, the proper way to say that is they're not like terms. I like to say they're not in the same family. You've got to keep families together. All right. Now, is Mr. Y happy yet?
No, ma'am. So you would divide it on all sides.
We're gonna divide everything by negative 5y. Or I'm sorry, by negative 5. Positive 5. 5's cancel, we're left with y. 300 divided by 5.
That's 60.
60.
And 150 divided by 5 is just 30.
30 what?
X.
30x. Got to remember that last name. So does
And then
this,
you would just swap that?
you can swap it. It makes some people feel better to swap it. And if we do, remember the sign in the front has to go with the numbers.
Mm-hmm.
All right, so let me swap screens again. My computer's begging for mercy. I'm making it work too hard. All right, so here's what we just got. Y equals 30.
30x plus 60.
Plus 60. All right. This chart right here, this graph, it's kind of small.
Mm-hmm.
It's going to be really, really hard and honestly a pain in the booty for me to count out 30 and 60 spots on here. And then it's going to go way totally off the page. So can you think of something I can do that might help me not have to count so much?
You could divide the 30 and the 60 by 10.
I like where you're going with that. Instead of just straight dividing, I can count by 10. I can say this represents 10, this represents 20, this represents 30. So instead of counting by ones, I'm going to count by tens on
By
everything.
tens.
All right, and this is going to be 60. All right, so we know y equals mx plus b. What is my starting point in that? Y equals mx plus b.
B, which is 60.
B, which is 60. That's perfect.
So you would start at the top. And then would you put 30 over 1?
Yes. So this is 30 over 1. That's rise over run. And is my slope positive or negative?
Wait, the slope?
Uh-huh.
So you're talking about the 30?
Yes.
Yeah, okay, that's positive.
It's positive, so does that mean I'm going to be walking uphill or downhill?
Up, but you can't, so wouldn't you make it negative?
No, we have to leave it the same. So if I'm right here and my slope is positive, I'm always going to be walking uphill somehow. So somehow, even though I'm starting at the top of my chart, I've still got to make it look like I'm walking uphill. There's a way that I can do that. And instead of going up and to the right, I can go down and to the left. So if I start here and I go down 30, 10, 20, 30, and I go this way. So when I connect my lines, you see how that's going to look? I'm still going uphill. So let me do it one more time so I can get another point. 10, 20, 30, and 1. hang on a second. Do you remember what I told you about these?
Mm-hmm.
We had said that we were going to count everything as if it were 10. We don't have to do that on the x-axis. We can leave these. We can leave these as 1, 2, 3, 4. That's okay. And I think that would help our graph look a little bit better. Because if we don't, it's going to be real funky. All right, so let's connect our lines. Nope, that's not going to work. So there's my line. Now I have to remember that as I'm doing this, these stand for 1, 2, 3, 4, but these are 10, 20, 30, 40, 50, 60.
Mm-hmm.
You need to make sure that it's labeled that way so that whoever else might look at this can see it. You good on this one?
Yes, ma'am.
All right, let me clear it. All right, number 6 says negative 4x minus 40x minus 80 equals 0. Is that in my y-intercept form?
No, ma'am. Because the X is in the front.
Right, that one is all kinds of ugly. So I need to rewrite that. Negative 4x minus 40y minus 80 equals 0. Right. So I'm trying to get this ugly thing right here into my pretty BFF y-intercept form. And I'm going to use this funky saying right here, don't call me after midnight, to help me remember the order. Who am I trying to make happy? Who am I trying to get by himself?
The Y?
The Y. Mr. Y is a grouchy old man. He wants to be in this room all by himself. He wants to be in this room all by himself. All right. So remember, everything moves as a unit until we get to the very end. Right? Do I have anything to distribute?
No.
No, nothing to distribute. Do I have anything to combine? Any families that need to be put together?
No.
Do I have anything to move?
The negative 4?
Yes, negative 4x. How am I going to move negative 4x?
You would do plus 4x on both sides?
Absolutely. What I do to one side, I do to the other. I'm going to cancel those out. I'm going to bring down what I have left into my brand spanking new equation. My 0, doesn't matter that much.
So
right?
wouldn't you do plus 80 on both sides?
You got it.
And then after you would do divided by negative 40?
Hang on just a second. What about this 4x and this 80? Can I put them together, or do they have to stay separate?
They have to stay separate, so you would just do negative 40y equals 4x plus 80.
You are exactly right. Very impressed.
And then wouldn't you do divide by negative 40 on all sides?
Yes, ma'am.
That would cancel, so you're left with y.
I think that's right.
I can't see it.
Y equals negative 1/10 x minus 2.
Oh, okay.
I think that's right. Is it in y-intercept form? Is it in the form that makes me happy? Y equals mx plus b.
Yes, ma'am.
Yes, it is. All right, here we go back to our sheet. This is the equation we came up with. Let me draw my grid or my axis. Right. All right, here's my equation.
Mm-hmm.
I'm looking for my y-intercept. What is that?
And so that would be the -2. So you would start at -2.
I'm gonna start at -2. Now,
And then you would do rise over run. So the slope is -1. So you'd go down -1 to the right 10.
I know that it's negative. So if I'm here walking, am I going uphill or downhill?
Downhill.
I'm going downhill. So that's what my line's got to look like somehow. So I'm going to go down 1 and to the right 10. 1, 2, 3, 4, 5. Ooh. Tell you what, it doesn't matter which way I go, I'm going to have a problem, right?
Mm-hmm.
Do you remember what we did on the last one?
You go back.
We did how we had the y-axis stood for 10 and the x-axis stood for 1s.
Oh, so that would just be, you change the 10 to a 1.
We could do that. We could do these as -1, -2. What would you want to do on the x-axis?
You could go by -10, like -10, -20.
We could do that. We could do 10, 20. We won't necessarily do negative because over here it becomes -10, -20. I was thinking 2s, but you know what? That works. So we're starting at 2. We're going to go
Down 1 and then to the left once.
down 1 and to the right 1. Because I'm trying to make it go downhill. See, if I make this line, I'm going to be walking downhill, right?
Yes, ma'am.
And if I go down 1 over 10, because this is actually 10 spaces. I don't like doing it this way, but when you got a little graph, you do what you got to do, right?
I did it the opposite way. I think I did.
What do you mean?
Like, I did the dots wrong, but like, I started 2, I went down 1, and then I went to the left 1.
If you go down 1 to the left 1, what does your graph look like? Which way are you going to end up walking?
Oh, you're going uphill, my bad.
Right. That's why I like to think in terms of uphill and downhill, because if it's positive, we're going uphill. If it's negative, we're going downhill. So you're always going to be the cute little chick over here. You got your little bow in your hair over here, and it's where are you walking. If it's a negative slope, you're always going to be
going downhill.
Downhill, right. So whatever.
I just got confused. So.
That's okay. That's why even for me, as long as I've been doing this, that's why I have to think uphill, downhill. I've been doing this for a very long time, and that's the easiest way that I can come up with doing this is think uphill, downhill. Whatever it is I have to do to make this line go downhill, and in this case, it's down and to the right. But you see, I could have gone up and to the left, right?
Mm-hmm.
Whatever it is I have to do to make this line go down.